All right, today you are going to do two problems to with Laplace. These two right here. I want to talk a little bit about this stuff here. First, we have our current Laplace chart. You can use all this stuff. You don't need all of it for everything that we're going to do here today, but we will eventually use all of this. You're also welcome to use the Laplace chart that I have posted in our team drive, shared drive. Anyway, so we know this is the formula for the Laplace transform. X, little x, Laplace is to big X, different variables, t to s. Little x prime goes to this, little x double prime goes to this. Notice there are no derivatives of the big X equation, and this is going to be a number. 0, Laplace is to 0. I could do that by putting a 0 in here. And I would have the integral from 0 to infinity of this entire thing would be 0, so it would be a flat line, so it would be the area underneath of it would be 0. That's why the Laplace of 0 is 0. You should have figured this one out recently. T to the n, Laplace is to n factorial over s to the n plus 1. And actually, 1 is a subset of this one. 1 would Laplace to 1 over s. If I plug in n equals 0, then this becomes a 1. 0 factorial, we define it as 1, and that works here. And there's reasons for that beyond just it works. And then we get over s, and then e to the at Laplace is to 1 over s minus a. And we can undo all of these Laplaces by going the opposite direction. So here are your two problems. What I want you to do is do problem 1, and then I'll tell you when to pause or whatever, and then you'll check your answer. And I will make a video for the full solution to number 1, and then I'll do the same thing for 2. And maybe I'll put up the solutions to both of them. Well, no, I'll do them one at a time. You do problem 1, and I will write the solution. So go ahead, pause now, do this first one. You're doing it with Laplace, not with another method. So this is the answer that you should get for this one. I'm going to walk through it. Remember, you should be doing it with Laplace. So if you did it using the old school method with characteristic equations and all that stuff and matrices, then make sure you do it with Laplace. But anyway, you should get this answer, and I will go through that process right now. So we want to Laplace this, and you know what? I will... All right, so I copied our information here so that we can use it. X, well, this, or x double prime, that is this. Notice this guy is, what is it? It is 4. And then this one right here, x prime of 0 is 2. So the Laplace of that x double prime is going to give me s squared. I should say we're Laplacing that whole information. All right, so that gives me s squared big X minus, all right, 4s, because x of 0 is 4, and then minus 2, and then I'll change colors for the next piece. So we'll go to green. Oh, green's not a good choice. We'll go to blue. So now I'm going to get this, and that is this guy right here. Notice x of 0 is 4 again. So I get plus 3, open parentheses. And inside of that parentheses, I'm going to put this piece, right? So I get s big X minus just 4. And then the last part is just this thing, so I get just plus 2 big X. Because remember, little x just Laplaces to big X. And then that is equal to the Laplace of 0 is 0. So now I can kind of, you could take some steps here and jump some things, but whenever I do that, I always wind up like dropping a negative or something like that. So I'm going to be really careful here. I get s squared big X minus 4s minus 2 plus, all right, 3 times those guys. I get 3s big X minus 12 plus 2 big X equals 0. And now what I can do is group my X terms and factor it. S squared plus 3S plus 2 equals, move everything else over to the other side. I get a 4S plus 14. Is that correct? Yep. So from here, I'll divide, and then I'm going to have to do some cover-up. X is 4S plus 14 all over. I'll factor it all at the same time as I divide. So I get S plus 2 times S plus 1. And then here's where I do my cover-up. That's something over S plus 2 plus something over S plus 1. So I cover this entire piece up, plug in a -2. That gives me -8 plus 14. Oops. -8 plus 14 all over -1, because that negative goes in, the -2 goes here. And then on the other one, when I plug in -1, I cover up this guy. This cancels with that to give me a 10 over, when I plug in -1 here, I get a 1. So I get X is equal to, that's a big X, is equal to, that simplifies to a -6 over S plus 2, and then plus a 10 over S plus 1. And I guess I will rewrite that a little bit as -6 times 1 over S plus 2 plus 10 times 1 over S plus 1. And then these are in this form right here. So I'll bring that down here. Oops. So these guys right here in this form right here, the S 1 over S plus 1 has an A value of -1. So that gives me 10 times E to the -t. I should, this is a big X. I'm going to inverse Laplace. Remember, if the Laplace goes this way, the inverse goes that way. And then I get -6 e to the -2t. That comes from this guy. And then that equals x of t. And I've got my solution. And if you were to check it with our old method, it would work. It matches. It is done correctly. So hopefully you're good with that. And I will do another video on the other one. Sorry, by do another video, I mean just continue with this video. You should do this one. You should pause, and when you hit play, the answer will pop up. Okay, the answer is, here it is right here, 3/2 e to the -3t minus 1/2 e to the -t. If you got that, great. If you want to listen to the solution here, even if you got it, that's fine, just to see it done. If you're good, you're good. And if you didn't get it, and you can just watch this and make sure that you understand it. Find what went wrong. All right, so I'm gonna Laplace all of this information right here. That includes the initial conditions. Let me pull up that. This right here is going to be this stuff. X of 0 in this case is 1, and x prime of 0 is -4. So when I do that, I get s squared times x. All right, then I get -1 times s. And then I get there's a double negative there, right? Because I got a minus sign here and then a minus sign there. So I'm going to write +4. And then we'll change colors to blue. This guy is going to be this right here. So that gives me +4 open parentheses. And then I put these guys right here because the 4 gets multiplied by the whole x right there. So that gives me s big X minus what's x of 0, 1, close. And then we'll go back to the main color, plus 3 big X equals, and the Laplace of 0 is 0. So let's do this line. I'm not going to try to skip steps. s squared, big X, minus s plus 4, minus 4s big X, and then minus 4, and then plus 3 big X. Look at this. This is awesome because those guys cancel. And then that's equal to 0. So I'm going to go big X, factor out. I get s squared minus 4s. Sorry, this should be a plus. I don't know why I wrote minus there. I'm sorry. Plus 4s plus 3 because the x get factored out, equals, on the right-hand side, it looks like I just have an s. Is that correct? Yep. So I can divide. X is s over s squared. Sorry, I'll just factor it. S plus 3 times s plus 1. Now I need to do some cover up. S plus 3 plus something over s plus 1. When I cover up the 3, I plug in a negative 3. In the top, that gives me a negative 3 over a negative 2. In the bottom, or in the s plus 1 piece, plug in negative 1. That gives me a negative 1 over a 2. So this gives me x is equal to, I get 3 halves times 1 over s plus 3 minus 1 half times 1 over s plus 1. And then this can be inverse Laplaced. And remember, e to the at, Laplace is 2, 1 over s minus a. That tells me that 1 over s minus a inverse Laplace is 2, e to the at. So when I inverse Laplace this stuff, I do get my x of t, that's my little x. And on the right side, I get equals 3 over 2. And then e, the minus a, is a negative 3 here, so e to the negative 3t, minus 1 half, and then this gives me e to the negative t. And that is my answer. And let's just make sure it matches what I wrote up there. It looks like it does. So hopefully you're feeling moderately okay with this stuff. And in our next session, we will either work with sines and cosines, or we're going to talk about what happens when this is not a 0 and what techniques do we need to be able to do it. So yay, Laplace. Sweet. Good. Doing it. Awesome. See ya.